Yeah, students, we are going to see a new topic today. It is called relative velocity. We already seen velocity. We saw acceleration also. But relative velocity is something to do with comparison of one velocity with another. Relative always means when you try to compare yours with others. So that's called relative. It is in comparison with one to another. So relative velocity also, it talks about the velocity of one with respect to another one. Now consider you are going in a train. Your train is a slow moving train. It stops in many stations and it's going in a 40 km/h speed. And you are getting an information that there is another train is going to pass by. So this train, you are expecting, yes, some train is going to come. So you're peeping in the window and seeing this one. As you see, your train is already moving with a 40 km/h. It is moving at a good speed. But you are seeing another train straight away coming, and it is just going past by. And it is in the speed of 60 km/h. Now, when you look at this train, you are there sitting here and looking at another person sitting here. How do you see these two people? When you see one to another, what do you do? So what you do is, you will be putting yourself into a state of rest, and you will be seeing this person moving ahead. So how do we do that? When you put yourself in a state of rest, you are going in a speed of 40 km/h with respect to the ground. Ground is when you see the trees are all moving fast and you are able to see that you are moving. But when you compare yourself with another moving body, what you do is you will put yourself in a state of rest and try to compare your speed with the other one. So when you compare these two speed, when you are sitting, in what speed you will see this train with respect to you? You will see this one in a speed of 60 minus 40 is equal to 20 km/h. This 20 km/h is called relative velocity of this train with respect to the yours. Relative velocity of train B with respect to A, it is 20 km/h. What did you do this one? How did you get this 20? Because you consider yourself to be in a state of rest and you compared yourself with the other one. So how much more is the velocity? What is the difference in the velocity? Of course, it is difference is 40, 60 minus 40. But in actuality, what you are trying to say is, you are not considering yourself as in movement. You are assuming yourself to be in a state of rest, and you are seeing the other train how it is moving. That's the way it is. When you are looking into this train, and when you are looking into the other person's train, you will be able to see the windows slowly moving ahead, and the whole train moves ahead, and it is actually going with respect to you. It is going in 20 km/h. So that is called relative velocity of B with respect to A. It is called 60 minus 40, 20 km/h. Now we will consider another instance. Let us consider the same instances. Let us not make this direction. Let us make this direction in the opposite direction here. This is VB going in 60 km/h. And you're going in this direction. The train is coming in the opposite direction. Straight, it is coming in the opposite direction, and you are here. So when you're seeing this opposite direction, what happens is, you will see always the opposite train is coming so fast with loud sound. It just passes by in a zip. Have you seen that? What you are actually doing here is, you are again considering yourself to be at rest. When you consider yourself to be at rest, you are trying to impose your velocity on this one. It is already going in an opposite speed. So when opposite speed VAB is equal to, right, now 60 minus of minus 40. Why it is minus of minus 40? Because already the minus sign you should put. Your train is in opposite direction to the other train. Your train is in 40 in opposite direction. This train is going in this direction. So minus of minus 40. So it becomes equal to 60 plus 40 is equal to 100 kilometers per hour. When you see from here to the next train, you are seeing this train in a speed of 100 kilometers per hour. That's the reason you will feel this train is going exceedingly fast. But it is not as fast. It is 60 only. But when you see in a moving train, you are already moving in a train and you are seeing another train moving in the opposite direction, you actually see in 100 kilometers per hour. This is called relative velocity of B with respect to A when two trains are moving opposite. This is same direction. Hope you are trying to kind of understand about what is relative velocity. Let us imagine another situation here. What if both the trains are going in the same direction itself? So train A is going in the same direction, 40 kilometers per hour, and train B, this is also going in this 40 kilometers per hour. Both of them same speed, parallel tracks. This is also going in a track, this is also going in a track. Parallel track is going exactly same speed. Then what you will see, what is the relative velocity of A or relative velocity of B with respect to A? What happens here? So you will impose this one on the other one. So it's going to be equal to VBA is equal to 40 minus 40 is equal to 0. So you will find your window is here and opposite window is coming almost traveling the same time. No difference, no change. It seems to be you are also at rest and you are also at rest. It will be the same. If you keep on looking at them for after a long time, it looks like both of you are in the same state of rest. So that is the actual thing. You are imposing your speed on the other one in opposite direction and you would feel yourself to be at rest. So that's a way in this, it is called relative velocity of one with respect to another. Now we will read the definition of relative velocity. What is the definition of relative velocity? The relative velocity of B with respect to A. The relative velocity of an object B with respect to A, when both are in motion, it is the time rate of change of position of object B with respect to object A. Time rate of change of position with respect to B of object B with respect to object A. So that is what basically relative velocity means. There's a definition. Now we are going to consider the formula, how the formula will evolve when you consider the relative velocity. Let us assume there is body A starting from 0 at origin and body B again starting from 0 at origin. Maybe both of them they are starting in the same particular time, but B is having a higher velocity VB and A is having a lesser velocity VA for our assumption. So they are already gone through, started accelerating now. Afterwards it goes to the same velocity because it's going to be having a uniform velocity. It starts going in the uniform velocity after appreciable time. Now you start a clock at this point of time. Here is a time t is equal to 0. Here is a time t is equal to 0. You have started the time over here. So when you start the time over here, then you start the time and it keeps on going. You will find this point of time at a particular time t. You stop the clock. When the clock is stopped, you will be able to see there is a difference in position here, which has gone ahead. VB has gone much ahead, which is now laid back. VA is already laid back. There is a difference in the timing. Now that's difference in the position. Look at this one. Time rate of change in position of B with respect to A, that it is called the position with respect to time is called relative velocity. There is a change in the position. Now look at this one. This is already having, what is the total velocity of this one? The displacement is displacement upon time. That is called velocity. Displacement upon time. That is what this velocity is. But what is the comparison here? The comparison is the time rate of change of position. That is a change of position from here of B with respect to A. That displacement upon time, it is called relative velocity of B with respect to A. So we'll try to understand a little more about how it works here.